Hello. So in this video we'll talk about the laws of cosine. First, a little overview. In the last video we were talking about the laws of sine. Maybe you noticed that to use the laws of sine you have to know a pair. Like, for example, if this is angle B, you have to know the side B as well. Like, or over here. So you have a pair like this, which you do have to know. So the angle and the side which is opposite of the angle, like here and here. And in general, when you're calculating on non-right angled triangles like these four, you have to know three values. Okay, you have to know three values to calculate the fourth. In right angle triangles you only need to know two sides, or an angle and a side, and then you can like look at the formulas. In Pythagoras, for example, you just have to know two sides, then you can find the last one. Or if you want to use sine here, you have to, for example, know the angle A and C, then you can make A the subject. When we are talking about right angled, or sorry, non-right angled triangle, we use these formulas, and we have to know, for example, yeah, we have to know three values so that we can figure out the last one, so number 4. Okay, so these two situations we have here, they are related to sine, so this is, it goes there. If we have a situation where, let's say, we know the two sides that are standing next to an angle, then it is laws of cosine. Or if we do know all the side lengths, it is also this one you have to use. In your formula booklet, this one is the only one for cosine that are given. I have created another one up here. Let's say you know the angle B, for example, then you just switch out the letters. So if you change A with B, you have to change the other letters as well. You can try and have a look at this and this, then maybe pause the video for 30 seconds and try and figure out what should this equation be. If you're switching this A with a C, what do you want to write there? Pause the video for 30 seconds and I'll give you my answer after that. Okay, so if you look at it, it should say B squared. Sorry, maybe it should be A first. Of course you could use B as well. So A squared plus B squared minus 2 times A times B times the cosine of C. So this letter there is always it's not the angle, but it's, yeah, if this is capital B, this is small b, so the opposite side of the angle, you could say. Just be careful with the words opposite and adjacent. We do not use them in triangles which are not right angled. So let's have a look at this example. If you know the sides 7 and 9 and you have an angle here of 30, you cannot use the laws of sine anymore, because remember, you have to know a pair. You do not know, we have to know this side if we, and this angle, if we want to use the laws of sine. We do not know that in this case, so we have to use the laws of cosine. And let's say we want to calculate the length over here, that is small a. So we can just use the formula as it stands here. So a squared You should of course write the formula first. Since it's up here, I do not want to waste time on writing it again. I'll just insert the value. So b, that is 9, so 9 squared plus c squared, that is 7 squared of course, minus 2 times b, which is 9, times c, which is 7, and multiplied with cosine of 30. You put that into your calculator, and then you take the square root of the number coming out here. Where's my calculator? So it is 9 squared plus 7 squared minus 2 times 9 times 7 times cosine of 30 degrees. And okay, I'll just do it in 2 steps. So you get 20.88. If you do it like this, you should write down all the decimals, otherwise you'll get an error. And then you calculate this. So you take the square root of the answer. This is a trick you should know as well, because this number, if you type in this number, you will actually do an error like I have done here. If you do this on your calculator, you use the answer button. It takes the last answer. Since it contains more decimals than there are shown here, it will include those when you write it like this. You just you can see it here as well. So there are more decimals. So this is the way to do it. So the answer here is 4.57. So 4.57. So the distance over here, or the length of the side A, is 4.57. Okay. In the next example, let's say you want to calculate the angle A. What is angle A? In this case, again, you can see that it looks like a situation we have up here. So you have to use the laws of cosine. So just insert into this formula. So it says, so A, that is 6, so it is 6 squared. 6 squared, which is equal to B squared, which is 9. 9 squared plus C squared, which is 7. Square that, minus 2 times B times C, which is 7, times cosine of the angle A. Now you want to make cosine of A the subject. So at first you subtract. I hope it's okay if I subtract 2 numbers. I first subtract 9 squared on both sides, so I get this. Then I subtract the 7 squared on both sides. Then we are left with minus 2 times 9 times 7 times cosine of A. This thing here, that is just a number, right? Negative 2 multiplied with 9 multiplied with 7. So this is, you can see this as one number. This is one number. You just divide. You want to make cosine of A the subject at first. So you just divide with that number on both sides. The green number. So cosine, 6 squared minus 9 squared minus 7 squared over that number we have there. So negative 2 multiplied with 9 multiplied with 7, that is equal to cosine of A. Cosine of A. And then you take the inverse function of cosine on both sides. So to that fraction, that is equal to A. Is it okay if I write it like that? I hope you understand it is just not to waste too much time. Then we put it into a calculator. So what does it say? It say that you should take the inverse function of cosine to this fraction. So first I make a bracket divided with another bracket. So it's 6 squared minus 9 squared minus 7 squared divided with negative 2. You have to push this button. Negative 2 times 9 times 7. Oh my goodness. What is wrong? What is wrong is that I forgot to add in a or dot into some of the numbers. I'll just do that now. Otherwise, this is the exact value, and you want an approximate value, right? So it is 41.8. So 41.8 degrees. Yes. Now you know this angle. Let's say if you wanted to calculate C now, if you wanted to calculate this one now, since you know A, you could use the laws of sine, because now you have a pair. You have this pair, right? And then you can, yeah, use the law of sine, or you could use the laws of cosine again. Just the one we have written here if you want to calculate C. Just remember that if you need this result in another calculation, like if you wanted to calculate C and you needed this one, you have to use all the decimals over here. Otherwise you'll get a big error. Okay? So that was it about those two formulas. A neat little thing you maybe should know. This is just or we could look at this one. This is actually just an extended. So this is maybe mostly for the high level ones, but anyway, it's a thing you should know, all of you, I would say. This is just actually an extended version of Pythagoras. So let's say you have a right angled triangle. Let's call it ABC. So C is the hypotenuse. If the angle C is right, like it is over here, this value, it will say cosine to 90. And what is cosine to 90? Remember the unit circle? I'll just draw a unit circle down here. Now I think we made the point green. Now I take the point here and I move it until the angle is 90 degrees. So the point is there. So cosine to 90. Remember that this was equivalent to the x-coordinate. And what is the x-coordinate of the green point? That is 0. You can check it on your calculator as well. So cosine of 90, it gives you a 0 because of this. Since this is 0, you can see um, the green part here, that will vanish because this is 0, and if you multiply the 0 with some other value, you're left with Pythagoras. See? So yeah, that's it for now.